Hello everyone. Okay, so what we were doing last time, we were trying to separate or split our data set to two parts. One, the training data set, another is testing data set. And then for training data set, we had independent variables, and then for the training data set, we had dependent variable. Also for testing data set, also we had independent variables and dependent variable. Okay, so let's go back to the node 23 and copy and bring everything to the new node. And I'm going to change this 25 to 30. And I'm going to run this and then run this. What happens? I should have random state. Am I right? Here, random state. And now it's fixed. And then to get some information, we are going to print this here. So we have our independent training set, testing set, and dependent variable testing and training set. So what I said last time, I said we are going to fit a model, linear model. The first one will be linear regression model. And then we can evaluate the model performance using what? Using our training data set on the tested data set, right? And then what we are going to do, we are going to make prediction on the test data set. So we are going to use our test data set to evaluate our prediction and calculate the prediction using the MAE, which is the mean absolute error. So I'm going to create the raw, and then now that we have testing and training data set, we will feed a model, evaluate the model performance using the training data set on the testing data set. Then we make predictions on the testing data set and will calculate the predictions using the mean absolute error, MAE. Okay, so more about MAE. What is MAE? So mean absolute error will actually given any test data set, this mean absolute error of our model refers to the mean of the absolute value of each prediction error on all the instances of the test data set. So what is this? Given any test data set, MAE of our model refers to the mean of the absolute values of each prediction error on all the instances of the test data set. And then this prediction error is the difference between the actual value and the predicted value for the instance, for each of the instance. And then I can write down this as a formula that prediction error is equal to the actual value minus the predicted value. So do you remember what this formula reminds you of? And this is the participation point for you. If you can remember from the past that what was this formula similar to, it was similar to another formula I talked about when I was talking about linear regression. So tell me what this formula reminds you of and what was the other formula or value that was similar to this, and explain to me why you think it's similar to that. Okay, so the MAE measures the average magnitude of the errors in a set of kind of forecasts without actually considering their direction, their association. And this measures the accuracy for continuous variables. For example, the MAE of 3 on average will say the forecast is off by like 3%, especially if we are talking about MAE in percentage. So now let's create, continue and fit the model. So we want to fit the actually linear regression model on the original data set. How we do that? First of all, I'm going to bring linear regression attributes from the sklearn.linear_model, import linear regression. Is it correct? Yes. And I'm going to create a model. So I am creating a variable named model, and then I'm creating instance of this linear regression. Let's see, everything is fine. And then consider this as a kind of empty model, right? And I'm going to build this by fitting this model. And then there are two arguments. One is the independent variables, the training one. So I said we are going to create a model based on the training set, right? Well, training data set. Did I run all of this? Let me run all of this again. There is a button here, actually you can run, you find it and run all the cells. You can do that. Run all the cells, all above, all of this. You can go through all of this. Okay, so we fit the model. What else we do now? We create y hat and this y hat is the predict. So this is the what is that? One of the attributes of linear regression. So predict is one of the attributes of linear regression. After actually fitting it. Okay, so predict what? Now that I created, I fit the model, I'm going to predict the model using what? Using the independent test. So imagine this as giving the x values to the model, right? To see what is the y values. So this will be all the predicted y, right? Let me write this down here. You created a model based on the training data set. You created a model based on it. Then you fit that model. Then you are giving some x values to this model to predict the y values. And then what are these x values? These are the independent tests, right? Okay. Run this. And then y hat is going to be just a set of array of numbers based on the x values, based on the independent test. We are going to have a y hat for the first column, y hat for the second column, and for each of them. And oh, sorry, what I said? You have just one y model. Y equal, for example, x1 plus x2 plus x values, right? You use all the x values gave to this model, and this is y hat. This is the predicted y. So it will be just one whole array, right? Will be all the points that your kind of linear regression line is going to give you as an output of predicted y. Okay, good thing I caught my mistake. Okay, so what's next? What is next is we are going to calculate MAE. Now let's calculate MAE, mean absolute error, right? How do we do that? We are going to get a method from this package, metrics. What is that method or attribute? Mean underline absolute underline error. Is this correct? Yes. So using this attribute, you are going to calculate the MAE of this model, the predicted y you created. So you are going to use the dependent test values and compare it with y hat that you created here. Right? And you are going to subtract them. This method will do that. Subtract these two to get the error possible. And then what is the value of MAE? Let's print it in a very chic way. We will say MAE 0.2 floating % MAE, right? Good. So this is the MAE value, the base one, base MAE. So now we are going to keep this and then create other models and compare with this MAE to see which data set gives us a better result. Okay, so I thought it's better if I keep like 3 digits after decimal, because later you will see I have to compare different MAE and some of them are very close to each other. Okay, so your result, when you are going to do this, your result will be definitely different. Why? Because these are all based on random kind of selection from your data set. So we are choosing 30% of our data set randomly to be a test data set, and the rest 70% is going to be trained data set, and it's going to be randomly. So if you do this, you will get a different training and testing data set, and then you will have different MAE, right? So what we did, we chose a training testing data set, then we feed a linear regression model, and then we calculate MAE, and now we are going to use a method that we call that isolation forest, and this method helps us to remove the outlier, detect the outlier and remove the outlier. How? First of all, we are going to import sklearn. We already, actually we didn't do an ensemble. We didn't do this. So I'm importing sklearn ensemble, and then I'm going to write down iso equal, and this one, and then there is an attribute here, dot isolation forest. So what we are doing, we are actually, in another word, let me write down, we are doing this from this one, import this one, right? So both of them are correct. Either you can use this one or this one, and if you are using this second line, you don't have to connect the sklearn ensemble. So let's do this. I hope it works, because previously I had hard time. I was receiving error. Okay, so contamination is a number between 0 to 1, and let me just try it. Okay, good, I didn't get error. I will explain all of this for you. Y hat now is going to be iso.feed underline predict, and then we are going to use the independent training set. And look at y hat. What is y hat? Y hat is just a binary value, 1 and 0. Some of them are fit, some of them don't fit. So we are going to create a mask and y hat. They both are the same, and I'm going to choose those that are not equal to 1. So mask are all of those that are not 1. So if the array has 1, it says false. If the array has not 1, it will say true. So false for 1 and true for 0. So now we are going to create our independent train, and the dependent train, how are we going to create that? We are going to choose the independent tray that are true, means the mask that are not 1. These are all 1, right? It's going to choose those that are 0 in this array, in the array of mask. And then, well, if I actually separate them, it's very easier for you to understand. Okay, and then dependent train is going to be only those that are mask is 0. Okay, so independent train are all the values, the predicted values that are masked, means the one that fit predict shows that are 0. Then the next step, we are going to get some information about the independent shape and dependent train shape. So now you will see what happened exactly. And then what about test? Running this. Okay, so now what this says out of all the independent and dependent variables we had in our original data set, which was this much, just this much of them, means 112 rows remained for us, means the rest were outliers. So this is not that realistic. And if you actually, I know you will also have this problem. If you run this again, it's going to decrease the number of independent and dependent variable remained in your data set. Why? Because see here, I'm replacing each of training data with the one that remained for us that are not 0. So let's cut this, put this here, cut whole thing, and let's put all of this together. So I'm going to run everything again. This is my dependent and independent variable. And then here I'm going to run all of these things together. So now again it's showing me 112 rows remained for us. Okay, so now what I'm doing, I'm going to for this set, what I have created, this new data set I have created by removing the outlier, and just these remain. So let me comment this. This is the training data set which doesn't have outlier. So it's funny because now we had 1599 rows in our data set, and just this much remained, means eliminated all the other rows that were outliers. So this is not realistic because my data set was not a kind of machine learning data set. It's just to practice and see how this kind of method will work. Okay, so now I'm going to feed the model on this new data set. I'm going to create a model like exactly same as here. And then let's call this M with capital, M with capital, M with capital. And the y hat now, let's keep this as a lowercase. And now I'm going to create MAE just to change this, and then y hat a small, and then MAE. So let's see what is the MAE after reducing the data set. And then this one is MAE of the original data set. Okay, let's see, let's run all over again. So I'm creating an independent and depending variable here. I'm going to run the whole thing. Well, what is this now? Okay, so MAE before removing the outlier. Oh wow, it didn't change at all. It's still the same thing. Okay. So what I'm going to do now, I'm going to bring all of them together so to remove any possible problem or error. Okay, so I'm creating the data set based on just values. Then I have a dependent variable, then independent variable. Then I'm splitting the data set to training and testing data set, right? And then printing some information. Then we are fitting a regression, linear regression model. Let me put this here also. And what else? I have created a model. This is the first model I created for the original data set. And based on this model, I'm creating a y hat. And then what we are going to do, we are going to calculate the mean absolute value for this y hat. Okay, so we have capital Y hat here, capital model here, and then MAE is capital, Y hat is capital. So there are two different other packages. I'm going to bring them here. And then I'm creating isolation forest method from sklearn ensemble, and then now I am creating y hat predicted y using fit predict attributes of ISO. Then I'm creating an array of those that are outlier and those observations that are not outliers. Then I'm going to choose just those independent training observations that are not outlier, and then dependent variable that is not outlier, just those rows that is not outlier, and then printing some information here. And what we are doing next, we are going to create a model. Let's use the capital M, what's that, lowercase m, and then fitting the model, because we want to see what is MAE for the fitted model on this new data set, right? And then we are going to create a y hat, which is the model predict independence test. Oh, now I know what was wrong. So the model that I changed to capital here and here was changed here, but it was not changed here. So this was lowercase still when I changed this. So that was good. I went through all of the lines and see what's going on, and maybe there is a mistake or anything like that. Okay, I created a y hat, and now I have created MAE, which is different from this capital MAE. The y hat was capital for this, and this one y hat is lowercase, and everything should be correct. Let's see. Okay, good, very good. See, that's why now the MAE is different. So previously, did you see the MAE was identical for the original data set and the kind of reduced data set? Okay, so, well, this is a mean absolute error, right? Mean absolute error must be lower. If I'm kind of creating a better data set, if I'm improving the data set, so the MAE should be smaller. So now this one is higher, means reducing the outliers, which were too many outliers in this data set. Again, because this data set is not a good data set for machine learning purposes. If I had gene expression data set, it would perfectly improve. But this is not a correct data set. We are just using this data set to see how we can remove outlier, and actually that was good, because now you will see different method can be really ruining a data set if we choose a different, or an incorrect method, right? Okay, so let me run this again, because see the MAE changed. If I run it again, it will change again. Why it's happening? Okay, that's your question, the question that you should answer. Why? I mean, I actually mentioned that before, but now just to know you were listening to some of the part. So why the MAE is changing when I run this over and over? Why this happens? Explain that to me. Okay, so this is for this lecture. We went through one method, and the method was isolation forest, which is a decision tree model, actually, to remove the outlier to improve the data set. And then next time we are going to learn three more methods that is based on MAE improvement, or not improvement of MAE based on removing outlier. Okay, we'll see you later. Take care.